Okay, here's our video for 5.9c, Simplifying Radicals Day 2. So in this table here, we're going to break it up into quarters and review some exponent properties. So the first one we're going to talk about is power of a power. So let's say we have something that's already raised to the power. So we have a to the m. And let's say we raise that to another power. What we do is keep the base the same and multiply that m and n together. So it'll be a to the m times n. And these exponent rules we did in the fall, so I'm not going to explain why they work right now. We're just going to review how they work. The next one is power of a product. So a product is when things are multiplied. So we're going to have two things multiplied, and then that is raised to a power. So let's say our two things are a times b and raised to a power m. We can rewrite that as a to the m times b to the m. It's like the m gets distributed in. And then power of a product. Product is something that is being multiplied. We can do something similar with a division or quotient. So power of a quotient So let's say our two things are now being divided, a over b to the m power. And again, we can sort of distribute that m into each piece, the a and the b, and we can rewrite this as a to the m over b to the m. And then the last thing I want to write is something we've been working on in this unit, and it is rewriting as a radical. So let's say we have a to the m over n. We actually learned two ways to rewrite that, but we're focusing on one way today, and it is this. Write your radical first. So there's my radical, my base is a, my root is n, and then I'm going to do the power on the outside of the parentheses. And I'll talk more about that setup when we do the problem. So we have three problems we're going to do. They all are set up the same, just numbers have been changed. We're going to hyper focus on this one problem type. So starting with number one, you'll notice that we have a quotient raised to a power, and then in this quotient, in the numerator, we have a product. So we're going to be using all these rules at some point in this one problem. So I'm going to start by noticing that there's three chunks to my problem. There's a number chunk, the 4, an A chunk, and a B chunk. And each one of those is going to be raised to the 3/2 power. So I'm going to rewrite this as 4. Now, remember, the 4 doesn't look like it has a power, but when there's not one written, we understand that it's 1. So it's really 4 to the 1 times 3/2. Let me write this better. It's just the exponent that's times the 3/2. So 4 to the 1 times 3/2, a cubed, so a to the 3rd, sorry, that was funny, a to the 3rd, I can speak regular, times 3/2. And then in the denominator, it's b to the 4th times 3/2. So we're going to keep, we're going to focus right now on the exponents doing that multiplication. So 3/2 everywhere is a fraction, and when you multiply fractions, you multiply across the top and across the bottom. So let me give these denominators. And now my 4 rewrites as, so multiply across the top, that's 3, across the bottom is 2, so 3/2. The a rewrites as 9 on top and 2 on bottom. And the b rewrites as 12 on top and 2 on bottom. Now this 12 over 2 simplifies to 6, and none of the other uh, fractions simplify. So now what I'm going to do is look at this 4 to the 3 halves, and I'm going to come over here and rewrite that in radical form. So my root is 2, my base is 4, my power is 3. Now this is a skill we've already been practicing, but what we haven't done is simplify it from here. So we're going to do that today. We're going to do inside the parentheses first. The square root of 4 is 2, and then the power second cubed. That means 2 times 2 times 2, which is 8. So 4 to the 3 halves simplifies to 8. And then we have a to the 9 halves over b to the 6. So the reason why we rewrote the radical as the power on the outside is because when you take a root, you're making your number smaller. So when it's in parentheses and you're following your order of operations, you do parentheses first, exponents second. So in the parentheses, I make my number smaller, then I make it bigger with the power. The other direction is sometimes harder. If you do the power first, you're making your number bigger, and then to figure out the root can be hard to do. In this problem, it's kind of either way, it'll be fine, but when these numbers get more complicated, it's easier to go smaller first with the root and then bigger with the power. All right, so we're going to do that same process here on number 2, a little bit faster now with a little less explanation. I have my 3 chunks, number, variable, variable. Bring the 2/3 exponent into each chunk. That's going to give me 27 to the 2/3, r to the 9 times 2/3. Remember that 9 is over 1. And then the bottom we have s to the 9/3 times 2/3. So focusing on my variable exponents for just a minute. Multiplying across gives me 18. Across on the bottom gives me 3, and that simplifies to 6. And then this one across the top is 18. Across the bottom this time is 9, and that gives me 2. So my variable exponents are now finished. So let's look at 27 to the 2/3. 27 is my base, my root is 3, and my power is 2. So the cube root of 27 means what number multiplied by itself 3 times is going to give me 27. Okay, or if you want an x here. And that might be trial and error for you. That's okay. Start small, take 2 times itself 3 times, 3 times itself, 4 times itself, etc., till you get what works. And what you'll find is that it's 3. Okay, because 3 times 3 is 9, times another 3 is 27. So the cube root of 27 is 3. And then we are squaring that. So that means 3 times 3, which is 9. So that's my final answer there for the number chunk. So now I have 9r to the 6 over s squared. And I want you to pause the video and try number 3 by yourself before you come back. So here's my setup. I'm going to work the variable exponents first, multiply across the top and bottom, gives me 36 over 4, which is 9. Across the top and bottom here is 12 over 2, which is 6. So now let me simplify 9 to the 3 halves. Rewrite that with a base of 9, a root of 2, and a power of 3. So square root of 9 means what times itself twice is 9, and that answer is 3. And then I bring my third power down. 3 cubed means 3 3's multiplied, and that is 27. So my final answer is 27 x to the 9 over y to the 6. That's it.